Welcome to module 11 of database management system. This will be on advanced SQL. Before we start, let me quickly recap what we did last week in the 5 modules. Last week we totally spent on discussing first the introductory features of SQL, how to create data and how to write basic queries, and we studied about all different kinds of SQL operations, theoretic operation, handling of null values, aggregation, nested queries and so on. And then we did an intermediate level of SQL query formation in terms of join, expression, views and integrities, different kinds of SQL data types, and importantly authorization. In this context, we now take up some more of the SQL features which are somewhat advanced, and we will try to understand how SQL can be used from a programming language and familiarize with functions and procedures in SQL. This will violate some of the basic premises that we started with in saying that SQL is a declarative language only, because as you understand functions procedure as procedural language features. We will see how to handle those, and we will take a look into another important feature of triggers. First, with accessing SQL. So, this is the module outline, accessing SQL from a programming language. So, this is just kind of an abstract view that you can think of, that what we have been doing so far. Naturally, there is a database which has primarily two things, schema and tables. Of course, there are many other things, there are index, there is authorization, there are triggers and all that, but this is a database which stores everything. And so far we have been dealing with only this part of the information, that I can write certain SQL query to define table using table names, attributes and certain logic, and that goes through certain query processor, works on the database to get me either create the desired effect, either that is creating table instances or creating index or extracting certain relation values, defining some views and so on. So, all these have to happen through an SQL interface. So, this has to happen through an SQL interface. So, whatever system we are using, whether you are using MySQL, Postgres, Oracle, Sybase, SQL Server, whatever you are using, that has some interface through which these SQL queries can be executed. So, that is kind of a standalone complete system, but in general we will have lot of more requirements in terms of the application. For example, the application might require some graphics. SQL does not have support for graphics. Application might require certain numerical algorithms to be executed, might require some geometric computations to be done, intersection of polygons to be computed and so on and so forth. It might require some network programming and so on. So, there is a need to do all these, and certainly these are best done in terms of certain native language. That could be C, C++, Java, C#, Visual Basic, Python, any of the native languages which has support for variety of different tasks. So, what is critical is, can we make a bridge between these two? That is, can we take the advantages of the SQL domain and the advantages of the normal imperative procedural programming domain together? That is, I can do some graphic representation and then certainly go to the database, extract some information and then present it in the graphics, and vice versa. For example, whenever we access say Gmail, we get to see them in terms of an HTML presentation, which is some kind of a graphics rendering. But all the mail entries certainly come from some database. So, somewhere there is a connection by which when I say get my inbox mails, and somewhere the information goes over from this to the SQL query up to the database, and the result is brought back to me. I see that in the HTML page here but here there must be certain mail database where all these information exist. So, what I am trying to come at is, it is critical that the application programs or high level programming, normal programming languages, native languages should be able to interface with SQL. And what we discuss here is two different mechanisms for this interfacing. The first one is using a connection library, and this is what I will specifically show you. So, if you are using a connection library, then you have a set of APIs, application programming interface. These are basically functions in that library, so that with that application can connect to the database, because certainly the database is somewhere else, it is a different server, and send an SQL command to the database server. So, that you can say that this is what I want, and then a result is computed. The result of that computation, the table can be brought back, those tuples can be brought back to the application program. Mind you, when we are here, when we are sending the information in terms of the database server, we are talking SQL command, we are talking about attributes, tables of the SQL space, whereas when I want it in the program, I want it in terms of program variables. So, there has to be certain correspondence made between them. There are a variety of tools available which allow you to do this. JDBC is very commonly known, which is specific for Java. You have an open database connectivity APIs, which has different versions for different languages. These are the common languages that it is used with, and as we will see later on, that there is another mechanism for doing the same thing called the embedded SQL. We will come to that later. So, JDBC is a Java API. I will not go into details here. If you know Java, you should be able to quickly look up. So, it communicates with the database by opening a connection, creating what Java calls a statement object, and executes the query using the statement objects, and that is used to send the query as well as to get back the result. So, Java is object oriented, as you know. So, statement object is used as an encapsulation which travels between the Java program and the SQL query processor, and sends the query, gets back the result, sends the query, gets back the result, kind of. There is exception mechanism to handle errors, which is common for Java. ODBC in contrast does a similar thing, but since it is to cater for different languages, it has got a softer model, it has got a less powerful model. It is a standard application program to communicate with database server. So, again it has to open a connection to the database, send queries and updates, and get back results. So, these are the three basic things. These three are the three basic things that certainly needs to be done if I want to easily work across the application programming domain and the database programming domain. So, applications such as GUI, spreadsheet, etc., can use ODBC. So, here I am just quickly showing you an example. We will talk about application programming more in a later module. So, this is a Python example. So, Python for this the ODBC for Python is known as PY ODBC library. So, you need to import that, and then using that you can connect. So, if you have to connect, you have to say which database, who is the user, what is the password, because authentication needs to happen. So, SQLS is a database here, and with this user with this password is connecting. If that is successful, you get a con object, and on the con object you have something what is known as a cursor. Cursor is nothing but, if you think about it's kind of a pointer. So, it can be used to point to either a row or a whole query or a table. So, you get back a cursor object. So, then this is, if you look into this part is nothing but a pure SQL query. So, you take that as a string and pass it on to the execute method of cursor. So, what it does is, so this has done the first task, which is connecting to the database. Now, you are basically putting the query to the database in terms of saying that this execute. Similarly, so that will get executed. So, the table is created, naturally there is no result to get if you have created a table. Now, you do an insert. So, again this particular record, you can see that within this double quote, this whole insert syntax, you take that as a string and just give it to execute as a parameter. The third that you do is do a select. So, you have done this, you have inserted a record, created a table, inserted a record in that, and then now you are doing a select. So, certainly you expect one record to come back. So, these are the SQL executions and then your get back result. So, cursor has another method which is known as fetch one. So, what it will do that if your result table has multiple entries, then the cursor will start with the first row, and a fetch one will bring the whole of this first row as a row vector. So, it will bring in as all the components as one, as a Python string, and then you check whether it is empty or not. If it is empty, then there is nothing to bring back. So, you are done. So, you break, otherwise you simply print the row. So, you are printing that, and then you go back again, this is while true. So, what happens is the cursor will advance to the next row and get you the next row. Again you do the same thing, go back, it will come back to the same, but once you get an empty result, you know that there is nothing more to proceed and you break. So, this is what is illustrated. Then there are some more, this particular record is deleted, then again another record is inserted, another select is done. So, this is how a native program, here in this case Python, can interact with the database and do any of the SQL tasks that we were doing earlier with the SQL interface. Now, we can be done from the Python. So, that is a basic ODBC mechanism. I particularly chose Python to just give you a different flavor. You can we will have assignments on doing it for C and using JDBC on Java as well. Now, I will come back to the same interaction issue, but this time you can see that I am using a different diagram. The database is the same, this part is the same, the query processing is same, but instead of having a connection library, now I have put the SQL query itself as a part of the native program, the C program. So, this is what is called embedding. So, you say I embed, I put the SQL as a part of C, but naturally SQL is not C. So, we need to put certain additional syntax in C, so that I can directly write SQL as a part of the C program. I am talking about C again just as an example. This is true for several other languages which can be used for embedding SQL within them. So, this is called embedded SQL. It works for C, C++, Java, Fortran, etc. And the language, native language in which you are embedding is known as the host language. And basic form of these languages allow that come from the system R. So, what is important is this particular statement exec SQL. This exec SQL written inside the body of a C program will tell the C compiler that this part is not C, this part is actually embedded SQL, and it will be treated differently. It will be compiled by the SQL compiler within the C compiler. So, that is the basic structure. So, exec SQL, and then you put the pure SQL statement, the embedded SQL statement. So, let us go forward and see some of this. There are different syntax for different native language embedding. So, to be able to connect, you say exec SQL and connect to server username using password. So, we saw similar thing in terms of ODBC based connection. These three information needs to be specified: which database server, who is the user, what is the password. So, here you say that in this form, and this particular statement you can write as a part of the C program. Now, naturally the question here is in the earlier case, when we are using the connection library, your results came back through the cursor, which you then could deal, because the cursors are necessarily objects in your native language. So, in Python the cursor was a particular object in the PyODBC library. But now you have embedded the SQL in terms of your C program. So, naturally the results or whatever you are doing in C, which needs to have a communication with the SQL statement, need to be differentiated from the SQL names themselves. So, any native language variable that needs to be treated in SQL will be marked with a colon preceding it. So, credit amount, if we say colon credit amount, so it becomes a SQL variable provided credit amount itself is a C variable. So, that is the basic connection mechanism. There are far more details in that, but I am just giving you the glimpse. Now, any region where you write the SQL, you can write it as exec SQL begin declare section and end declare section. This is where you specify what are the different C variables, C declarations that need to be used for this SQL definition. I will just show you an example soon. So, that similar to the ODBC style, you will declare a cursor. So, this is to write the embedded SQL, you use declare C cursor for such and such SQL query. So, then that C variable C will become your handle in the C language to be able to handle the query results. So, here is an example. So, you can see that credit amount is a variable in the host language. So, you are using it in SQL with colon credit amount, which says that it is this host language variable. So, that you can set a particular credit amount and go with that, and this is the query, and you have set a cursor on that, which you can make use of in the exec SQL. So, let us this is the example continued. Let us look at other features. You can, once you have set a query, you can actually execute that by the open statement. So, you say exec SQL open C the cursor. So, that will execute the query that you have associated with that cursor, and then once that has been done, then you can fetch the results into that cursor one by one tuple at a time. Once you are done with all that, then you simply close. So, let us look at a example. This is a program which will which prompts the user for an order number and retrieves the customer number. I mean, given an order number, it will retrieve the customer number, salesperson, status of the order, and it will display that as the retrieved information on the screen. So, here is the C program. It starts on here with the main. So, you can see that this says that SQL include SQL CA. SQL CA is the communication area. So, there is a exchanges going on between the C program and the SQL program. So, the area that is used by both for this transaction is known as SQL CA. Then you have the declare section. So, you are saying these are SQL exec declarations. So, these are, but within that what you have are pure C declaration, but all the declarations of C that are put within this can be used in SQL query with a colon at the beginning, so that the value can be exchanged to the SQL CA. Then in the next you are specifying what will happen if you have an error. So, you say SQL, look at this exec SQL, whenever SQL error go to query error. So, it will go to this label. If it is not found, that is no result is there, it will go to this. So, you are making sure that if there is some error that happens in the SQL part, what will happen in your C program, and then subsequently you have simple C program which reads the order number, and after having read that you are doing this. So, what does it do? Exec SQL is to say that this is embedded, this is the select query starts, the fields, the relation, the condition, and then there are 3 attributes. So, you are setting an association with 3 variables in the C program. So, if I want to, the result of this select will be a table of 3 attributes, table of 3 columns. So, we are giving a name to each one of these 3 attributes in terms of our C program. So, there is a cust ID. So, I say the cust ID attribute in SQL is colon cast ID here, which is basically cast ID variable in the C program. Let me clean up again. So, this is cast ID, this is in SQL, this is my C program, and this is my C program variable in SQL, which corresponds to this. Is similarly order based. Similarly, this is in SQL attribute, this is a array of character here, and this is a correspondence. This is a correspondence. So, now you can easily see that once this has been done, I will be able to get all these values here. Normally, the program would be longer, you will have to iterate over the cursor as you did in the ODBC case, but in this case since we are using one order number, we know that there will be only one record. So, we have not showing the iteration on the cursor. So, once you have got this, you are using those values to print out the result, and in case this query has got into some problem because of SQL, then it will automatically jump to SQL query, this particular label. If it has got a bad number, which means that no such record was found, it was a null table, then it will immediately take you to this. So, this is how the embedded SQL work. So, these are two different styles, the ODBC style and the embedding style are two different styles. If you depending on the preference, you can use that. Earlier days people used to use more of embedding. I believe that now the preference is more for the ODBC kind of connection oriented system, ODBC, JDBC kind of, because they are certainly more programmer friendly. This you can do updates through embedded SQL as well. So, I will not go through the details, you can just go through this and understand that. Let me move on to the next advanced part of SQL, which is function and procedure construct. Now, mind you, again these are the two models that we have I have already shown you, the two models in which the application program, the native language program and the query language can interact, the ODBC mechanism and the embedded mechanism. But what we are now empowering is so far our basic premise was that this side is procedural. I discussed this at the very beginning, and this side is declarative. So, in SQL you do not say that how you find out a result, you say what you want as a result, these are more like predicates, and in C program you cannot specify what you want as a result, you rather say that do step 1, step 2, step 3 and you will get this result. So, C program is all full of functions. Again, I am talking about C as a placeholder, it is true for most of the programming languages we use otherwise. So, they are procedural languages, so procedures in C are functions, whereas in SQL you had select from where kind of conditional clause. Now, what we are saying that SQL also in later version have allowed certain functions and procedures which can be part of SQL. It also has allowed certain imperative constructs like case, like loop, like while, repeat, those kind of, to make certain kind of procedural programming easier in SQL. And naturally, these again can be used in conjunction with the connection oriented applications with the native or embedded oriented mechanisms. So, we will just take a quick look into some of these function and procedure features. So, this started coming in from SQL 1999, and you can have functions and procedure written in SQL itself and function and procedures written in external language or the host language also. So, both of them are available. What is interesting is some database systems support functions which are table valued. Functions, we always know functions return you objects only, but in SQL you can have functions which are table valued, which return you functions. So, and certain imperative constructs have come in. So, there are several databases have their proprietary constructs and all that also. So, at this level of the course, since we are not focusing particularly on any specific database systems, we will not talk about those, can do enough in terms of the standard SQL itself. So, this is how you define a function which looks very similar to the SQL definition, create function, give it a name, certainly here are the parameters, and here is the return type. So, if you are familiar with C, C++, Java, you will I mean, it is just that the syntax is different, but the elements are the same. There is a begin end in the scope, and this is the pure SQL that you are writing here. So, this is a function which is not a function in C, this is a function in SQL. So, this you can write this function in SQL, and once you have written that function, then you can actually use that. So, if you look at the function is department name, then separately I am writing a query, I am using this department name as function. So, whenever whenever this query will get executed, this function will be called and the corresponding values will get returned. So, this is the basic mechanism. Okay. So, there are SQL functions have several details which you can go through. It has return naturally, and you can have table functions where it can return table. So, the syntax is given, it is clear to see what will happen if you return a table which is computed from the select from where query that you have within the function. You can have SQL procedures which just performs some action, but does not have a return value, so to say, and you can use them. You can declare and call those procedures explicitly. Procedures can be functions, and procedures can be overloaded as well if you are on SQL 99. Now, there are several language constructs as I mentioned. SQL does allow while, repeat. So, I am just covering them in terms of completeness. It is not that these are frequently used features, or I recommend that you do a lot of them right here. If you need to do procedural thing, it is always better to do them outside, but in some cases it may be easier to code a query if you can write a while, repeat kind of loop. You can write a for loop which iterates over the records of a table, which is certainly very convenient. So, if you want to do something over the records of a table, compute something, that the for loop will become easier. You have a conditional statement case. Actually, we have seen the case already. So, which is very easy in terms of coding many of the features. So, here are some of the then you have exceptions. So, I am not going through these in depth, but this is just to making you aware that while SQL continues to be predominantly a declarative language, it does have quite a bit of procedural support, which in an appropriate time can be used if required. So, you can look up the manual for that. And there are a whole lot of things you can do with the external language routines. That is, you can write a function in C and actually call it from SQL. It is just doing the other way around. Earlier, in terms of embedding or in terms of ODBC, a C function was executing a query. Now, you are doing the reverse. You are saying that I can write a SQL query which uses a C function that already exists. So, there are external ways of binding. I will not go through these slides in depth, because again you will have to come a certain way before you can actually start using such features, but get to know that there could be, as from SQL you can use any external language library, and if some library is good for certain computation which is needed for your query, which is a non-database kind of computation, then you can make use of these external language routines. So, I have put together all the basic features that external language routines will need, but again I would tell you that there are benefits, but there are a lot of drawbacks in using them, and I would not recommend that you frequently use these features. You should primarily restrict to SQL programming, and then anything that you need to do in the native, you should go to choose your language and do that. There are security issues also that you will need to understand here. Finally, before we close, I will just mention another feature called triggers. Triggers are very important. A trigger is a statement that is executed automatically when something happens in the database. So, you want that well, things are happening and well, I want to know if a particular value has exceeded a certain level, or if something has become null, or some validatory things are happening and so on. So, how do you know that? Because a database is being accessed by hundreds and thousands of people and with hundreds of tables and millions of records. So, triggers are a mechanism by which you can set that under this condition I want a trigger, I want something specifically to happen. So, again they were introduced in 99, but earlier also triggers were there, but in 99 standard they became formal. Earlier they were somewhat differently structured. So, you might find that the system that you are using for practice, the trigger in that may have a different format and semantics than what we are discussing here. So, the most common triggering events are insert, delete, update. So, if something some update is happening, so I can say that after this update I want such and such things to happen, or I can during the update I can want that, well, I am doing an update. So, there is an old value which is typically referred to as old row, the row that is getting updated, and there is a new row, the new set of values that are getting created. So, I might want between the old row and the new row that certain things happen. So, I can say that well, just look into this. So, again the syntax is all similar. Create trigger, this is the name of the trigger, and this is the condition before update of text is a relation referencing new row as row, n row. So, this is the new value that we set. Now, what is saying? Saying that for each row, what you do when n grade is blank, n row dot grade is blank, that is if if you are updating and you have you are going to update a grade value which is blank, then you simply set it to null. So, it is possible that the grade that has come in, and grades are characters, and what has come in from the input and is going to get updated is show a certain grade to be null, because it may not have been decided. Now, you do not want those blank values to be present. You want, because blank cannot be checked. We have checkers for null and so on. So, you want to set that to null. So, trigger can make this thing happen, because otherwise how will you know what value is actually getting changed. So, there could be several ways trigger can be used. For example, this is showing one that as you change the grades, then certainly based on the grades credit earned value is computed. So, as the grade is changed, if it is now grades have been entered say for 200 students. Now, after reviews grades for 3 of them are getting changed. So, how do you know that for those students the change of the grade may impact the computation of the earned credits. So, you would like to update that earned credits, or it may or may not be required. So, the trigger will tell you that after update, so whenever the update happens, you take the old and the new value, n row and old row, and then you are putting some conditions, that if the new row is grade is f and is not null, old row is grade or it is not null, then you try to do this. So, if it was failure and if it continues to be failure, new grade is not f. If it is f, then you do not have to do anything. If it is null, it do not have to do anything. But if it was f or it was null and now it has become a different grade, then certainly the computation to update the credits earned is required. So, and the trigger gives you the right point when you can do this, because otherwise you will not know in terms of millions of updates happening when this particular thing is going on. triggers can be on statements as well. You can this I will leave for your reading, but you will have to be careful that triggers sounds very interesting, and what happens particularly with the early stage of programming, people get overboard with triggers and start using them severely, but triggers do have a lot of overhead. So, you should not many of the things that triggers can do can be done through other means, for example, by materialized views and so on. So, as we go along, we will mention that these are the problems that need to get solved by triggers. Otherwise, normally you should think twice before you actually use triggers. So, there could be different other ways of solving the same problem, and because you have to keep in mind that triggers are expensive, because once you have triggers, then actually internally database for every update, if you have an update trigger on a field or a relation, then with every transaction, with every change, the database has to check if your trigger is true or not, and so therefore, there is a cost to that. The other thing is there are triggers are for the live execution. So, if you have offline, for example, you are loading the data from a backup copy, or you are replicating your database at a remote site and so on, then you have to put off the trigger. Otherwise, falsely the triggers will start happening, and that may have a catastrophic effect that might trigger off different alarms and all that. So, you have to be careful with triggers in that manner. So, cascading executions and all those. So, to summarize, we have and this kind of closes our direct discussion on SQL. So, we have introduced the use of the very important aspect, the use of SQL from a programming language, the interface between the native language and query language boundary, and that is something which will be extremely useful for application programming. And we have familiarized with the imperative extensions of SQL, the procedural extensions of SQL in terms of functions and procedures that you can directly write in SQL. And we have just introduced the concept of triggers, so that you can sniff what is going on in your database. So, there is quite a few other features of SQL as well. Majority of them are advanced features dealing with OLAP and several others, which I chose to skip at this level of the course. So, this will close our discussion on SQL, and next we will move on to the design of the database, looking into the algebra and the modeling.